Okay. So what's the first thing I have to do to make sure I can actually solve the equation? Set it equal to 0. Get it in standard form. Is that in standard form? No. So what do? Subtract the 4n. Okay. There's no like terms on the left side, so it just moves it over. And then check for GCF. We have one of n. And then we need to factor our quadratic. How do I factor this one?
So it's with the multiplier.
Yep. So product of negative 12, a sum of 1. So what are my two numbers? So 3n squared minus 3n plus 4n minus 4, grouping those intentionally so that the GCF is easier. Okay? 3n is the GCF, leaving me with n minus 1. Positive 4 is the GCF, leaving me with n minus 1 again. And this GCF that we found in the beginning is just following along with us. Okay? So my final two factors, or final three, I guess, are going to be n, 3n plus 4, and n minus 1. Okay, so those are all three of my factors. If I have three factors, how many solutions am I going to have? 3. Okay, so the number of factors always matches up with the number of solutions. So now that I have it completely factored, zero product property says I can do what? Continue to solve. Set everything equal to 0. n minus 0. 3n plus 4 equals 0. n minus 1 equals 0. And then that was already solved for us. Woo. Subtract 4. Divide by 3. That would let me. There we go. And add 1. So I get my three solutions. 0, negative 4/3, and a positive 1. Easy peasy. When I did my factor by grouping, my GCF became n minus 1. Now, I want to make note for your test coming up. It's going to include factoring and solving kind of mixed together. You need to be very diligent about what questions want you to just factor and which ones want you to solve. The big difference between the two is going to be an equal sign. If you don't see an equal sign, you're just factoring it. But if you see an equal sign, you're going to factor and then use the factors to solve. So you need to make sure that you're aware between the two, because if the question asks you to solve and all you do is factoring, at best, that's half your points, if you do it right. So you need to make sure you're answering what the question wants and not what it doesn't want. If it just wants you to factor and you go solve, that's wrong, because you made an expression to an equation when it wasn't supposed to be. Word problems. We're going to be sticking to either the formula is provided to you, or it's a simple formula that you should know, area formula, even Pythagorean theorem, but I don't think I have it for I think it's for my algebra class. We're using Pythagorean theorem. But a formula that has a squared in it, or a formula that's provided for you that will also be a quadratic. The biggest thing with word problems is interpreting your answers. When I have a quadratic, usually, how many answers do I end up with? 2. So if I'm given a word problem that asks me for something specific, the width of this room only has one width. It's got a width, it's got a length, but it's not going to have two different widths. So it's going to be really important that you can interpret the answers that you get and choose the most appropriate one based on the context. But we can read through the question and we want to write an equation that we can factor and solve. So we start with the length of the room is 2 meters less than 3 times the width. So right there we've got an algebraic equation or an algebraic sentence that we can write as an equation that's going to help us solve through the rest of it. So I don't know what the length is. What can I use to represent length? L. length of the room is. What does is mean in math? 2 meters less than. Minus 2. The order makes a difference. Okay? So I have 2 less than something. If you have 2 less than $10, how much money do you have? 8. 10 minus 2, right? Not 2 minus 10. Okay? So when you have the subtraction, make sure you end up getting in the right order. So I've got 2 minus 2 from something else. So I'm going to have this blank because I need to fill in something else and then subtract 2. Fill in something else. And I need 2 less than 3 times the width. Let's represent 3 times the width. 3 times the width. And I need 2 less than that. So there's my length. The area of the room is 96 meters squared. So I have area is 96 meters squared. And I want to find the width. Okay? What's my formula for area? Length times width. So if my area is length times width, my area is length times width. I know my area, 96. My length, I have this expression to represent my length, 3 times the width minus 2. And then my width, I still don't know, so times the width. So now I need to simplify and get it in standard form. There's a few things I need to do. What's one thing I can do to get me closer to standard form? One of them is distribute. The other is subtract 96. Okay? So let's start with distributive property. 96 equals 3w squared minus 2w. And then we can go ahead and subtract our 96. So I end up with 0 equals 3w squared minus 2w minus 96. All right? Now I need to factor. Anybody know my two numbers? Oops. Minus 96. Okay. So negative 18 and 16 for my factor by grouping. GCF? Just 3? 3w, leaving me with w minus 6, and GCF, 16, w minus 6. So my two factors are going to be 3w plus 16, minus 6. Yep. Both factors. Nope. Only if you have a third power. So the degree of the polynomial gives you the maximum number of solutions you can have. Since this is a quadratic, 2 is the maximum number of solutions. Okay? So I've got 3w equals negative 16, so w, God, I'm running out of room. W equals negative 16 over 3. Okay, So if I have a possible width of negative 16 over 3, does that make sense? No. So I can ignore that one. My other option, w minus 6 equals 0, w equals 6. My other option is 6 meters. Is that a reasonable solution? Yeah. So we had two possibilities. One of them was negative. We're off the negative. That makes sense. So you have to make sure that you're looking at the context and picking the correct solution. Here, the width is going to be 6. We can disregard the negative 5 meters. All right? It was a negative number that we can ignore because we can't have a negative length. It's negative 16 over 3. Yep, because it asked for the width of the room. One of our answers that we got, one of our possible solutions was negative 5, approximately. The other one was 6. If I asked you to measure negative 5 meters, you can't do it. You can't have a negative unit of length. So we disregard that answer because it doesn't fit in the context of the problem that we have, and so we focus on the one answer that does fit in the context. Absolutely. I ain't doing this for my health. Now, these type of verbose questions usually have an equation given. So don't panic with the amount of information that's there. No, focus on the equation. And you might have to fill in one or two pieces of information that's given. Okay? So focus on the fact, just kind of do a quick scan, and I say, okay, I've got a function. I have an equation, so I know I'm going to use that. Okay? So we look through, we got a small rocket launched vertically upwards from the ground with an initial velocity of 128 feet per second. I have 128 already in my equation. I don't need this. I can ignore it. It's already included in the function. Its height in feet after t seconds is defined by that function of air resistance neglected. How long will it take the rocket to reach a height of 256 feet? So how long will it take? What am I solving for? Time. Which variable represents time? T. Okay? Makes sense. Pretty straightforward. So we're solving for t. Solve for t. And if I look at my equation, I see, okay, well, t is one of my variables, so I need to solve for. It's quadratic, so I have to factor. But I also have h of t. And I can't solve until that's filled in. So what does h of t represent? Represents its height at some given time, right? So if h of t represents height, and I want to know, solve for time, how long will it take the rocket to reach a height of 256 feet? That height gets plugged into my formula. So now I have 256 equals negative 16 t squared plus 128 t. Side note, okay, for my sanity and for yours, mostly mine, please make sure I can tell the difference between your t's and your pluses. So do something to make sure that they are distinguishable. Write the pluses smaller. I do the little curly loop, okay, italicized, so that I can tell the difference between a t and a plus sign. Okay, so please make sure that you are aware of that, especially when you're showing your work, for the sanity of all people involved. All right, standard form? Nope, so what do? 0 equals negative 16 t squared plus 128 t minus 256. There is a GCF. What's my GCF? Bigger. 16. More specifically, negative 16. You don't want your leading coefficient to be negative. You do not want your square term to be negative. So if it is, your GCF is negative. Okay? Even if there's no other GCF other than negative 1, factor out a negative 1. don't want your leading coefficient to be negative. So negative 16, okay, leaves me with t squared minus what? Plus 16. Okay? Completely factored? Let's keep going.
Okay, so you gotta find the, so 4.
We have perfect square trinomial, y'all. Perfect square. When you take the square roots, multiply and double it, hey, we get that middle term. Perfect square trinomial. Take your square roots, multiply them, double it, gives us the middle term. So then I can just put in the plus or minus and square it. It's factored. Done. No, now it's just factored. I mean, it's all the time.
So if you do the little thing, you know how it's like t squared minus 8, and you do the little find the.
That's fine.
That's the same thing. But
Yeah.
okay, so you
T minus 4, right? Okay. So, I mean, we've got T minus 4, T minus 4. Zero product property set all of these equal to 0. Well, if you set 16 equal to 0, doesn't do anything. And I've got negative 4 for both of them. So I just need to do it once. Set it equal to 0. Time equals 4 seconds. Okay? So it takes the rocket 4 seconds to reach the height of 256 feet. Now I'm going to add in one more part to this question in just a second. All right, so part B is how long will it take the rocket to land? So instead of reaching 256 feet, how long will it take the rocket to land? I'm plugging 0 for 1. Okay? So again, we have to have enough context to solve the problem. So I have to, instead of plugging in 256 feet for the height, I want to know when it hits the ground. Ground, height 0. So I'm going to plug in 0 for the height. Okay? Can I erase this screen? Okay. All right. So, give me some more room. Okay? So we're going to plug in for the rocket to land. And when it lands, our height is 0. So 0 equals negative 16 t squared plus 128t. Now, luckily, it's already in standard form, so factoring becomes a whole lot easier. So let's factor this. It's a GCF of what? T. Because I don't have that constant term anymore. Now I have a GCF of negative 16t. Which leaves me with, set both factors equal to 0. If negative 16t equals 0, t equals what? Negative 16 times what equals 0? That's our zero product property, right? I have two things multiplied together that equal 0. What does that number have to be? 0. What's my other value for t? Okay, so I have two answers. Both are reasonable as far as time is concerned. I don't have negative time. I've got 0 seconds and I've got 8 seconds. Which one makes the most sense if I'm looking for when it landed? 8 seconds. What is time? What's happening at time equals 0? It's taken off. It started here on the ground, went up, and then after 8 seconds landed again. Okay? Interpret the context.